This looks to be a giraffe with a dog's face.
Good try, old friend. But based on the short curly hair, snout, eyes, teeth formation, body size, and collar, this seems to be a Bernedoodle groomed to look like a giraffe.
Deep learning is a subset of machine learning that uses artificial neural networks or complex architectures inspired by the human brain. Instead of learning from data with just a few rules, deep learning stacks many layers of interconnected neurons. Each layer picks out patterns, simple ones first like edges in an image, then more complex ones like shapes, faces, or meaning in sentences. It's actually really interesting how it learns in a loop. First, deep learning sends an input of what you want through all of its layers to get an output. Then it scores how poorly the output matches what you said you wanted. It then sends the mistake signals back into its layers and nudges each setting a tiny bit to reduce the errors for a better output. Sometimes it does this multiple times until finally it produces the output for you. Because of the way it learns and processes inputs through layers, deep learning can handle huge amounts of data and spot very complex patterns. That's why it powers things like voice assistants, image recognition, and language tools. The trade-off? Well, sometimes there are so many layers and so many neurons that it's hard to interpret how the output was actually achieved. Sometimes an input can go through billions of neurons to produce an output, so deep learning can feel like black boxes where we don't always know why it gave an answer. Most of the generative AI that teachers and students are experimenting with, like large language models, image generators, or adaptive learning apps, run on deep learning. Understanding the basics helps teachers see what's possible and where the limits are. Deep learning can recognize complex patterns like grammar or handwriting, but it doesn't understand like humans do. For example, it knows the patterns for words and letters, but it doesn't make meaning of words and letters. For teachers, that means outputs may look polished but still be biased, inaccurate, or missing context. If an adaptive reading app is built on deep learning, it might be great at suggesting the next text for a student, but it might also misjudge students whose language, culture, or learning style weren't well represented in the training data. Here are 3 things we could do to support students and their understanding of deep learning. 1. Don't treat deep learning outputs as unquestionable truths. Probe and verify. 2. Ask vendors if they can explain how their system makes decisions. And 3. Teach students the difference between surface knowledge and deeper abstraction, using AI as a mirror for critical thinking. Deep learning drives the most impressive breakthroughs in AI, but also the greatest challenges for transparency. We need to harness its strengths while demanding clarity and accountability. As educators, knowing how deep learning works helps us separate the hype from the reality, so we can make wiser choices for our classrooms.